very much. Now I'm going to share my file to you guys. Okay, and in the beginning of this slide, I'm going to introduce my expertise in the past when I received my postdoctoral training. And this film was taken from the under intravitreal microscopy, which is the sickle cell disease animal models. You can see this. You can see this film. Is taken from live mice, okay, and you see a lot of white cells interact with like elongated cells, like red cells, sickle cells. Okay, we use this platform to analyze what kind of white cells, okay, to mediate the sickle vasoocclusion in sickle cell patients. And we identify what kind of molecules mediate this interaction between the endothelial cells and the hidden leukocytes. And later on, we defined what kind of drug or reagent can solve this problem. This research turned me to study to working on biology of neutrophils and adhesion molecules in the future. So I'm working on adhesion molecules to dissect the mechanism of metastasis of tumor cells. Okay, and the topic of this presentation, I'm going to fill the two goals, two aims. The first one, to introduce you guys what is the pathophysiological mechanism of COVID-19, the first one. And the second one, I would like to introduce what kind of treatment current has been used in clinically, okay, and how to prevent COVID-19 spreading and infections. Okay, and I divide those slides into 5 categories. The first one show you some statistics and the impact, okay? And the second, I'm going to tell you introduce the structure and the life cycle and the transmission regarding this virus, okay? And third one is most important part of this presentation, immune response, and what kind of consequence will occur after suffer the COVID-19 disease. Okay, and the last one, I'm going to show you what kind of prevention of therapeutics. And the last part, I'm going to show you introduce the TMU background in research and the study, and I will introduce my program to you guys. Okay. Okay, let's flash back the onset. It's echo. Is my phone from me? I don't know. Okay, I may turn off my speaker a little bit lower. Okay. So now it's better now. Okay, let's look at the timeline during the onset of COVID-19. It was first discovered on December 8th. The first patient developed the symptom of Wuhan coronavirus. Less than 2 months, you can see until January 29 of 2019, it has been reported 132 deaths and 6,000 new cases. And this short period of time tell you this virus, at that time it was virus, this agent, infectious agent is very powerful. It's easy to spread from one person to community. Okay, and on January 23rd, this day is very important date. The Wuhan city was locked out. There's no one allowed to go in and go out. Country around the Asia. Okay, for example, Taiwan, Singapore, Thailand, Vietnam. Due to this experience and also SARS experience, we set a very strict regulation. We put the tourists from overseas 19 infection or pandemic. So you can see that we have a very low death rate. Okay, only so far, I mean, less than 20. Okay, that's an old data low. Okay, it's very, very low, and the fatality rate is very low too. Okay, and so we in the country in our region all perform very, very well. The data from WHO released on this data derived from March 9. You can see that almost 1,600 case was reported suffering this disease, and among them 2.6 million people died on that date. And more than 1.5% population on Earth contracted, and the population received the vaccine. So vaccine still is urgent for everyone to get it, and it's very good. I mean, it's very important. Well stabilized and also improve North and South America, America. You can see that the death rate and average death rate is much higher than average global death rate. Okay, they are more than also very important. And third one is medical resource. Okay, those factors will contribute to the mortality rate in a particular country. Okay. Okay, now we are going to tell the America or Europe, it will drop very, very significantly. You can see almost reach 40% drop per share in the stock market. Until now, on the January this year, it's kind of bad a little bit. Industry was hit so hard. Okay, you can see the shrink per share. Some industry sector are down to more than 50%. Okay, for example, the airplane, and the traveling, okay, this business is suffering so huge. And the state, the jump more 4% to 5% increasement in unemployment rate. Okay. And also some countries suffering in recession, for example, Canada, huge. And also European country, and only one country is China. Okay, it predicts has a growing around around region. And let's go back to commercial flight numbers comparing to 2019. You see there are more than 100,000 flights per month. Okay, but after the COVID-19, it dropped significantly. You can see in the April, less than 25,000 airplane number. Okay, and you can see the Thailand suffer a lot in tourist business, okay, very, very significant, including Indonesia, US, Spain also. And so from previous slides, I show you this, it tell you the impact is so huge in the economy in some, according to the UNESCO report, there are more than 1.38 billion school children or students that go to online course, okay, and because due to the closure of school. And however, most the teachers are not satisfied with the way that deliver the teaching because they feel effectiveness, okay, but it's the way, it's changing now. That's the reason why I'm sitting here to teach, to give a lecture. You guys use the Zoom, okay? But however, this is, it's a trend going to change the world in the way of teaching. And let's go to this slide to tell you one thing. People sitting at home, use their laptop, use their console changes. Most significant countries in Germany. They don't go shop, they don't go to mall, they don't go to shopping center anymore. They just mail order, okay? So they purchase another things, food, personal care, beauty sales. You can see that 35% increase in purchasing the food from the online, 15.8% to purchase the personal care. Okay, so it's suggesting COVID-19 changed the behavior in shopping globally. Okay, so e-commerce is the business, it is a future. Okay, and another industry benefit from the COVID-19, that's pharmaceutical company. So it is very important for students study medicine, study biology. It's a time for us, good time for us to seize this moment, this opportunity to develop a drug to cure new infectious disease in future. You can use the plants, you can use the herb, you can study chemistry, design the drug. Okay, that's our chance in the future. Okay, and okay, so in the previous slide, I just outlook the impact result from COVID-19. Now we are looking at how to determine this infectious agent. On 2020 January 7, okay, the first infectious agent was isolated and determined. Okay, you can see that this TEM picture was taken from the patient sample from the bronchoalveolar lavage fluid. You can see you can see that there's a spike body around the virus. Okay, and they determine that they are very similar homology into the bad SARS-CoV virus. Okay, and this picture, the picture B here, you can see the virus was stored in the endosome, in the cytoplasm. Okay, this is a typical feature of the coronavirus. Okay, and they incubated this virus into the cell culture, and they study their life cycles. And then you can see this picture on the left side on my slide. You can see these viral particles was sputting out from host cells. And in this picture tell you that the fusion between host cells membrane and the virus membrane. Okay, so budding is exocytosis is their mechanism to release their baby virus. Okay, here again demonstrate that the virus is destroyed in the endosome. Okay, and they look at another way using the SEM. Okay, give it a more particular shape to observe it, and you can see that this after incubation 2 hours to 48 hours, you can see the morphology of host cells is changing. Most of the time, most important feature is that the cell is going to spike like a pseudopodia structure on the cell surface. You can see that, and this is a very important structure which can assist the virus starting from the host cells. Okay, and look at the inside, you can see the virus is budding out of the cell's membrane and the enclosure endosome and the fusion of membrane. Okay, that's again tell the maybe possible life cycle of this virus. That's what I try to say, that's a pseudopodia structure or tentacle structure in the host cells after infection of virus. Okay, and so far there are 7 coronavirus has been discovered in the past. Okay, 4 of them we call them common coronavirus. For example, 229E, NL63, OC43, and HKU1. And there's no the case or death report in those 4 human coronavirus. The symptom just like a flu, okay, that's common cold, okay, it's not that severe. Compared to another 3 virus, we call them zoonotic coronavirus, which their original host is a bats or other animals. However, they can pass through into the human being, okay, they including SARS-CoV. In this pandemic is occurred in the 2002. Another one is 2013, the MERS-CoV, which is originally occurred in the Saudi Arabia. Okay, recently we got a COVID-19. And look at the death rate and the case. Okay, look at the first one, SARS. More than 8,000 people suffered in this disease, and 774 individual passed away due to the SARS. Mortality rate is 9.5. And for the MERS, as a probably around 2.5 case was reported at that time, and 861 report deaths. And the mortality rate is much higher among the 3 coronavirus, 35%. It's huge, it's severe. However, the COVID-19 virus, SARS-CoV-2 virus, you can see that 2.5 million people reported get this disease, and it's keep going, okay? And more than 2 million people pass away due to this disease. And I'm sorry, it's 2.2%. I mistake. Okay, the fatality is 2.2%. Okay, you can see that the mortality rate is the lowest, but the impact is huge comparing to other coronavirus. The reason why is that they are very easy to spread. Okay, that's a lot of hospital did not offer another ICU, did not have enough ventilator to help those people develop the pneumonia, need a ventilator to help them to breathe. Okay, that's the main reason. Let's look at those 3, compare the similarity and the difference between these 3 coronavirus. MERS, SARS, and COVID-2, their original host is the bat, and will pass through different intermediate hosts. For example, MERS in camel, and a civet cat in SARS. And for COVID-19, we don't know yet, but the people suggested the pangolin. Okay, we don't know that. And the way they transmit from the host, from the intermediate host, the animal to human, the way is still not clear, but I would believe that maybe it's the diet, maybe the direct contact of fluid, and still unclear for this COVID-19 virus. Okay, and the transmission from individual to society to other people through these 3 different ways. The first one, droplet transmission. Second is airborne transmission. The third one is contact. The way to transmit the disease is very important for us. We learn it. So in Taipei, our government put the regulations. We request the student, every individual need to wear the mask when they take a public transportation to work, to school, to shopping center. We need to wear the mask. It helps us to bring our much safer environment in the onset of COVID-19 outbreak. Okay, it's very helpful. Another one, maintain social distance, which can minimize the spreading of virus. I think prevention is the best medicine to me. Okay. And the symptom when for the patient suffering COVID-19, for milder symptom is probably covered with fever, coughing, fatigue, headache, sputum production, okay, something like that. But some people will develop very severe syndrome, okay, with a high fever, white count in blood, trouble in breathing, develop pneumonia, and leading to ARDS, lung failure, kidney failure, leading to death. Okay, that's the symptoms, common symptoms here. And comparing to the flu virus, all the three coronavirus has much higher incubation time, around 2 or 14 days. According to this data, so the government set the regulation, 14 days, stay in a quarantine hotel before you get free walking on the street. Okay, this can prevent patient spreading their virus onto the society. Okay, after you suspect that you got a contract this disease, you are going to do the test. Okay, and there are 3 ways to test. You got this disease, this virus or not. Okay, the most easy thing, you get a sample from the nostril, from throat using a cotton swab. Okay, and you got a sample, you can do the RT-PCR, you can do ELISA, these 2 methodology. PCR, in recent PCR, we use the LAMP. It's a loop mediate isothermal amplification. I'm going to briefly introduction this technique. They use 4 to 6 primers, not only 2 primers. Okay, so in the end of DNA amplification, they will they got the loop structure. Okay, loop structure of DNA is easy to detect. And second, they apply a different set of DNA, reverse transcriptase, RNA-dependent DNA polymers, which has a heat very stable enzyme. They can work at 65 degrees. So during the PCR machine, during the DNA polymerization, they don't need time for denature, annealing time. So it can save a lot of time for amplified viral DNA from the patient samples. Okay, because the time saving, because of high temperature, so you can increase the sensitivity and specificity for this methodology. Okay, so you can save the time, you can spend comparing to another 2 ways. Okay, another 2 ways, you can check the virus protein in your serum or not. You can check you have antibody or not in each individual. However, there are some limitation. If a virus titer is very low, it's very difficult to check by checking the antigen in the serum. Another one, you use ELISA to check your antibody production, but it cannot tell you I got infection or not. So RT-PCR is the best way. And they check the viral RNA best way. The course in Taiwan for payload, and Japan also similar. Okay, but I don't know. I have no idea what's the course in your country for the course for the screening of COVID-19. See a lot of white spot, the line on it, we call them bilateral opacity here, which suggests you got a pneumonia or infection. Okay, you can structures I mean, this virus is carry RNA. This RNA is positive RNA. What is the positive sense RNA? Another one is most important one for receptor binding. That's S protein. Okay. My goodness, stuck. Okay, they are very, very similar. Okay, and you see the 5' and O
Prof, I'm sorry, Prof.
translated
Prof.
into the
Prof,
enzyme.
we have
For example, RNA dependent RAAS it has a little big difference between the MERS. Okay, the more how have
Hello, Prof.
MERS
Jung Sang.
here protein there.
Hello,
Prof.
Have
We cannot hear
how can we stop
your sound.
Very significant.
Pardon us, Mr. Cheng.
Maybe try to close the video. To close the video.
I cannot your sound.
Must the whole gene is domain to and then to need vector one and S2 and S2 can receive information can receive and or the line that is to and different protein well it's I don't have it
Because if your face is
have it to it's feel I don't have it
it's recorded, if because if ready
should I turn it off and
to continue your face in
sorry sorry so I don't need to
it's me recording here.
good so control my slides so I that's a one part like so I don't need to get
Here.
sorry
Sorry.
because I'm going to continue okay I'm going to back to continue and whole life cytosis. In this, in the to the within the life and how to look at the life see firing cell they are key repeat the cycle in all messenger RNA from fast land we must is for structure and the probes through the exocytosis and into the onto entire assembly. This life cycle for us in the future, we can also use this and try into the to minimize into the what I'm going to mention later on. Okay, now I'm going to later on important I mentioned well in general later going to important and as and to amplify these RAAS the random in charge. I'm not familiar with the physiology of this.
Slide.
Like
Then
We're sorry for the inconvenience, Prof. I think the connection ran not too well. We're sorry for the inconvenience, Prof. I think the connection.
hello, can you hear it? Can you hear?
Yes, Mr. Cheng, we can hear you clearly now.
Can you hear me?
Yes, Prof.
It's clear?
Yes, clear.
Okay, good. Okay. Sorry about that little technical problem. I would like to share my file. Can you give me the permission to share my file?
Yes, Prof.
I need the permission to share the file. Okay, yeah. Okay, got it. Okay, got it.
Okay, maybe try the first slide first. The slide first, Prof.
Which one? Which is slide first? Which is slide first? Which is slide first?
This slide will
Which
be okay,
slide?
Prof, but still not clear.
Which is slide?
Okay, this slide will be okay, Prof.
Which is which is slide? Which which slide? Which 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 slide? Which slide? Which which slide? Which 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 slide? This one? Which which slide? Which 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 slide? Which slide? Which which slide? Which which slide? Which which slide? Which slide? Which which slide? Which slide? Which slide? Which which slide? Which slide? Which which slide? Which slide? Which which slide? Which which slide? Which which slide? Which slide? Which slide? Which which slide? Which which slide? Which slide? increase, which will increase the infiltration of leukocytes. Okay. Is pneumonia.
Just like yes.
Good treatment COVID system is very, very important, will impact a lot of clinical disorders. Keep in mind. Let's look at the COVID-19 virus. Look at the receptor, right? So breathing AC, no more AC signaling will most of angiotensin 1 and 2 will did not convert the short peptide and angiotensin 2 the one receptor, which make a blood flow, make the vascular tone smaller, okay, and leading to acute lung injury, and also making a vascular permeability increase, which will increase recreational leukocytes, and of course leading to ARDS and pneumonia. And you can start again. Here's a liver, secrete angiotensin nargin, and converting into angiotensin. Angiotensin 1 will convert to ACE into angiotensin. These two will will convert it by ACE to receptor converting enzyme. Okay, and this one enzyme will bound to another receptor, which can help dilation, antioxidant effect, anti-inflammatory effect. However, if angiotensin 1 and angiotensin 2 will cause vessel contraction, okay, increased salt and the endothelial dysfunction. Therefore, there's another option. These inhibitors may be for treatment of COVID-19 in the patients. So let's look at the impact during the COVID-19, because we know the entry and the ACE2, this enzyme. ACE2 was expressed over the, including the lung, including the kidney, GI, brain, CNS, eye, nose, heart, and so severe may damage heart or impairing different tissue, different organs. Some people will lose their they cannot smell anything, right? They don't have, like they cannot taste all the smell delicious the food. Okay, burn the eyes. Okay, so diarrhea. So their impacts are huge. Most of the case in the Japan can report a vertical from mom to the baby. So it's likely, as a Chinese scientist found the particles in the semen of male patient. Okay. Okay, so patient has experienced symptom of this disease, they are going to send clinical to the chest, and this picture they leave the of the acute respiratory stress syndrome over the 7 years old male, lymphoma, and the H1N1 infection. Okay, this case in the figure 8 show Taiwan during the admission of the clinical, very clean, clean the image, and later on it helped white spot, we call them pulmonary consolidation, the low lobes or lungs here, and over next 2 or 3 days, rapid deterioration. On the figure C, you can see a white spot, and later on you call them white lung. Okay, this progression is severe. Okay, and normal size, the heart is vascular structure difficult to for you know for the to do the diagnosis. And there's one major event, edema, occur in the patient's lungs, and heart very difficult to breathe in the patient. Later on will cause the heart failure in this period. Okay, in this slides, it's very similar to the previous picture. This patient suffering COVID-19 also will develop ARDS. Okay, you can see the progression. The first they registered into the hospital, and later on you can see the capacity lung. Okay, a white spot here, and day 5, day 6, day 7, day 8, they are you can see a gradual recovery, and you can see more dense lung tissue observed in the chest X-ray film. Okay, just use as a CAT scan to end the lung tissue. Okay, and here is actually standing histology sample. Okay, he's gathered from the
Halo, Prof.
Halo, Assalamualaikum, Mas Nuk.
Prof. Delay.
I'm really sorry.
Something still
Can you guys hear later, right?
still not clear, Prof, from here.
Okay, can you hear me?
Okay, how about you hear Prof Chan?
Can hear you. Yeah.
Pak Rizky, is it clear? We cannot hear clearly here, Prof.
I'm here to hear your voice. Okay.
Halo. Gimana yang lain, Mas Wah, apa terdengar suara Prof?
Halo, halo.
Still cannot hear, Prof.
Hello, can you hear me? Is it better now?
Yes, it's better.
So I'm going to share.
Yes, better. Okay, let's try to share again, Prof.
Okay.
They said you have the extra time, 90 minutes. For
Okay,
so it's
so I'm going to start from the life cycle. I'm going to slow down. Is that clear?
Yes, clear.
Okay, good. Okay, the life. Okay, I just mentioned, right, the S protein called spike protein is very important for entry or host the cells, and we'll go to endocytosis pathway. And in the environment and endocytes, the pH value is very low, which is very good for activation of protease and lipase in the endosome, which can help us to degrading the proteins and release RNA. So RNA can duplicate themselves, and during the after transcription translation will produce a lot of structure protein, and later on will assembling and through the exocytosis and release the baby virus into the outside of cells in situ. Okay, that's very important for life cycles, and it's a very good target for treatments. Okay, we can block entrance, we can target protease in the endosome, we can manipulate or stop the transcription and the translation, and we also can block the virus button. Okay, keep in mind. And a viral infection will cause two major events leading a progression of this disease. The first one will generating immune response, innate and adaptive immunity. Okay, some patient will has a milder syndrome because their immunity are regulated appropriate, but some people lose the control function and generate a lot of infiltration of neutrophils in the tissue, in the organ, especially in the lung and kidney, and leading to ARDS, a lung failure. Okay, and another very important pathway is ACE depletion. Okay, we know ACE is very important for binding, but also it's very important for maintain the normal function in RAAS system, Renin Angiotensin Aldosterone system. What is this RAAS? I'm going to mention in this slide for students if you did not take a physiology course. Okay, this system is very important to maintain blood pressure, maintain the fluid, especially during the dehydration. Okay, let's see this chart. Okay, during dehydration, right, a liver will excrete the angiotensin, okay, and will convert into angiotensin 1 by renin, excrete from the kidney. Angiotensin 1 later on will convert into angiotensin 2 by ACE, another enzyme, angiotensin converting enzyme here. And okay, and angiotensin 2 and angiotensin 1 will bound to type 1 receptor, which make vessel smaller. Okay, we call them vessel constriction, will increase the blood pressure. And another one, the angiotensin 2, will act on the adrenal gland to release the hormone, aldosterone, which can increase the resorption of water and salt. Okay, so here can maintain a fluid volume in the bloodstream. So this ACE system, ACE2 and ACE is very important system to maintain the blood pressure and the vascular tone. Okay, now we look at what's ACE2. ACE2 is an enzyme to convert angiotensin 1 or angiotensin 2 into the fragment of angiotensin, either 1 to 9 or 1 to 7. And these ligands will bound to type 2 receptor and a MARS-R receptor, which has an opposite function. Is that clear, everyone?
Yes, Prof. Clear enough.
Okay, okay, good. Okay, they show different opposite function comparing to angiotensin 1, angiotensin 2 mediated signaling. Okay, in this pathway will increase the vascular tone, cause the vascular relaxation, and with the anti-proliferative function, antioxidant stress, and anti-fibrotic functions, but it's less than, it's not inhibit, the inflammatory function. However, this one, if you go to this signaling, what happened? Vessel getting smaller, a cell start to proliferation, especially for the fibrocyte, and generate a lot of free radicals and the pro-fibrotic signaling. Okay, so irregular function of angiotensin 2 and the receptor will cause a lot of inflammatory response in different organs, for example, in liver, in the lung, in the kidney. Okay, due to time, I'm not going into very detail in this slide. Okay, let's go next one. These slides are very important. When it go into the cells, right, what happened? The depleting ACE2 for entrance. So now without the angiotensin converting enzyme 2, most the angiotensin will turn to the angiotensin 2 and go to type 1 receptor. What happened? Pro-inflammatory signaling, making value smaller, making endothelial cell the arrangement, a leakage. So will cause a lot of macrophage or neutrophils infiltrate into the lung, increase the inflammation or increase the chance to get the cytokine storm in this case. So that's the reason why immune response plus imbalance between the RAAS system will manifest the progression of COVID-19 disease. Okay, let's go back, look at this one. If you go to this pathway, you get the not good for our vasculature, in our tissue environment with high free radicals. Therefore, we can use some inhibitors blocking ACE, convert from angiotensin 1, angiotensin 2, for example, these blockers for treatment for the patient of the COVID-19. As we know, ACE2 are expressed all over the place in different organs, through the brain to the liver, lung, kidney, okay, even the prostate, okay. So the infection will cause systemic syndrome in the COVID-19 patient. And recently, there's a report that in Japan, they found a baby has the COVID-19 virus. It's the first evidence that vertical transmission from the mommy to the baby. Okay, so it suggests that this finding with COVID, how is it that it's respond to the finding from China scientists. They claim they found the virus particles in the semen of men. Okay, so you can see this virus, the impact in the disease is so huge. And this, I'm going to use this film to tell you the syndrome. ARDS syndrome is a lung failure, which is contributing to the death and mortality of the COVID-19 patients. And this, there's a picture. The patient was first day go to the hospital and take the chest X-ray film. You can see it very clear, right? It's good shape. However, during the second day, you can see the progression of this disease. You can see opacity on the lung, the white line. Okay, and later on you can see the progression, so many lines and white spots over the lung on the two lobes. After a couple days, after a couple days later, you can see the white lung, which cause a lot of edema and leading to the failure of lung. Okay, so ARDS and the edema is very important issue, cause the fatality in patient. This is the serial picture recording the recovery of the COVID-19 patient. Here's day 1, clear, and day 3, day 5 with the progression, a lot of a white spot here. That's it tell you the pneumonia is developed, and after 6 and 8 they recover. So I try to say use a chest radiograph is a good way to monitor the improvement or lung function or pneumonia. And beside the use the film, we can use the histological samples. Okay, this sample was derived from the patient or derived from control. Okay, you can see it's very healthy, a good thing. Evora here. However, you can see this one, it developed very thick wall, okay, on the lung here, tissue. And later on, you can see a lot of infiltration of leukocytes during the HE staining, a lot of neutrophils here and here also. So this evidence to show you that one thing, increased infiltration of leukocytes into the tissue, into the lung, is daily act behavior. Okay, I'm going to tell you why later. Okay, now I just finished ARDS system, ARDS, and now I'm going back to the immunity. From inactive form immunocytes, for example, neutrophils or monocytes or T cells, B cells. After their activation, they need to move or travel into the site with the inflammation or trauma sites or injury sites. They're mediated by a lot of different sets of adhesion molecules. For example, selectin molecules, for example, integrin molecules. Okay, those are the adhesion molecules and their ligands will facilitate. Can you hear me? Clear?
Yes, I can hear you.
Okay, good. So I
Clear.
continue, okay? Good.
Yes, it's okay.
Okay, so I'm going to introduce those set of adhesion molecule. We call them leukocyte adhesion cascade. Okay, here is a naive leukocytes, which without any expression or adhesion molecules, either on the white cells or endothelial cells on the venom. Okay, after trauma, okay, after cytokine release from the bloodstream, they are going to activate. They are going to secrete L-selectin, one or three selectin molecule, which will start with the first contact with the endothelial cells. Okay, they start to tethering or capturing. Then we are going to fast loading. Okay, mediated by P-selectin, another set of selectin molecules, and later on we'll upregulate E-selectin after stimulation of cytokines. Okay, then we'll slow down those leukocytes and make it slower and get a time to express integrin, especially beta-2 integrin, LFA1 or very late antigen. So what happened? They are going to move through the endothelial cell layer, either through pericellular, I mean move around between the two endothelial cells, the gap between two cells, or direct make a punch, go through the cells, then reach to the tissue. Okay, now I'm going to show you some film here. Let me try it. Okay, got it. Okay, you can look at picture A here. If you are a good surgeon, right? You generate a very minimal immune response. No tissue are damaged. So you can see the flow is good. No white cells loading, right? But after 10 minutes, what happened? P-selectin, which are originally stored in the granule, alpha granule, is going to release and express on the cell membrane. And then, as you mentioned, P-selectin is very important. Adhesion molecules can help the leukocytes loading through the venue. So you can see the loading velocity is very, very fast. Can help the leukocytes concentrate in a very short period of time to the target, to the trauma or injury, the tissue. And then later on, tissue is going to secrete a lot of cytokines. For example, TNF-alpha, which has increased expression of E-selectin. Okay, E-selectin with a very high affinity to the ligands. So allow the cells move very, very slowly. Okay, then we'll activate next event, integrin. The integrin will facilitate the migration, allow cells penetrate endothelial cells out the vessel and to the tissue. Okay, this event we call them leukocyte adhesion cascade. Okay, it's a very good way if you got a medicine or a reagent block this event, you can have a good treatment for the inflammation disease, especially chronic inflammatory disease. Okay. And when the cell go to the tissue, what happened? Especially neutrophils. Let's look at the neutrophils first. Neutrophils will release a different cytokine, which can activate more white cells. Okay, and also will release a lot of toxic substance, for example, free radicals, and it will release a lot of proteins, which will degrade in pathogen or digest and metabolize derived from the pathogens. And in the end, they also will release histone protein plus their DNA materials and genetic material to form the web. And those web can slow down pathogen spreading from the tissue. Use this methodology, these tools or those weapons to minimize amplification or enlargement of inflammatory sites. Okay, when they use all the weapons, they are going to activate their cell death program. In other words, apoptosis will occur. Then apoptotic neutrophils will uptake by particular cells. We call them activate form macrophage. Will clean up all the neutrophils. Okay. After we allow the neutrophils in the injury sites, what happened? They stop secreting IL-23 from macrophage. Okay. Without the IL-23, what happened? IL-17 is turned to inactivated form without the IL-17 are expressed. IL-17 is very important cytokine, interleukin cytokine, which can activate GCSF producing cell. This is a cytokine, is a growth factor, which is important for neutrophils production and mobilization from bone marrow to the bloodstream. Okay, using this system to regulate neutrophils infiltration. Okay, for the COVID-19 patient, they out of control these mechanisms. That's the reason why they got to increase the white count in bloodstream, or to increase the white count in the tissue, in the lung, or the injury site, for example, like kidney. Okay, this is very good biology for you students to understand it. Why, how come the white cell cannot be underregulated? It will cause a severe chronic disease or acute disease. Okay, let's look at it, the biology of the neutrophils here. They contain so many stuff inside. It has the protease, lipase, right? They got a free radicals here. They got a cytokines. They got a RAAS. They got the histone, the RNA. They got the elastase. So those information, a lot of people start on it. So they call them what? Proteomics or human neutrophils. So it is very powerful innate immunity, okay, to killing a pathogen and to homeostasis for healing process. Okay, that's the tell you neutrophils. The next one, I'm going to show you another set of innate immunocytes in innate immunities. Okay, that's a macrophage. In activated form macrophage in the bloodstream, we call them. I'm really sorry. We call them monocytes. And after activation, we call them macrophage. However, some particular macrophages exist or stay in the organs. For example, in the lung, you can see the alveolar macrophage. In liver, you can see Kupffer cells. Okay, in the brain, microglia, and in the keratinocyte, I mean the skin, you can Langerhans cells. Those spatial macrophage, they look at infection. They look at cell damage. Okay, they will clean up the war zone. They clean up. They uptake the apoptotic neutrophils. Okay, so during the inflammation, right, you can see this picture in the COVID-19 patient. Lung macrophage is sitting on the lung tissue. After infection, okay, our immune system will respond to it, and this surveillance soldier will find this intruder, okay, infection. They will release a lot of chemokine, for example, IL-1. Start transcription of the alpha interferon gamma B for generate more cytokine, okay? And these infected cells will go to particular apoptosis. We got another form, pyroptosis, which is due to stress because of loading of virus in the cells. Okay, eventually the cell is going to die, and this macrophage, what happened? They will release a different cytokine. For example, IL-6, MIP-1, MIP-2, and this cytokine will stimulate other or activate other cells, recruit more macrophage and the T cells. And later on, those and also this signaling, angiotensin 2, will damage the the integrity of endothelial cells. More macrophage will go into the tissue, and I just mentioned that the RAAS system will increase NF-kappa B activation and go to the nucleus, transcribe different inflammatory cytokines. Combine these two events, what happened? A lot of toxic cytokine will kill the infected cells and also will kill healthy, normal lung cells, will lead in edema and cause the ARDS, okay, lung failure, okay? And by the way, you can see that I just mentioned there are particular dendritic cells or macrophage around the tissue, right? And when they get a virus infection, will waking up those dendritic cells or macrophage. They are going to move it to a lymph node. I should tell you there are adhesion molecules L-selectin, which mediate loading in the lymph node for the dendritic cells and the lymphocytes. Okay, in this lymph node will activate T cells into CD4 positive T cells or CD8 positive T cells through MHC complex. Okay, and also can activate B cells into the plasma cells and shedding a lot of immunoglobulin, IgG antibodies. Okay, then we'll go back here to fighting the virus or infected cells in the lung tissue. So in this, did you still remember I just show histology assessment, histology sample? You see a lot of different leukocytes in there. Majority is neutrophils and some macrophage, and also has some T cell, NK cells in that slide. Okay, so you can see that in the healthy cells is under all the cells and adhesion molecules under check. There's no expression, no upregulating cell still in the tissue. After infection, you can see monocyte, NK cells, neutrophils are activated and mediated by a lot of adhesion molecules. They will cross over the tissue into epithelial cells, into the alveolars, okay, and then we're shedding a lot of cytokine into the tissue. These cytokines will lead in cell damage, including healthy, including infected cells. Okay. So what happened? if the people can regulate the recruitment or infiltration of monocyte, macrophage, T cells under check their release of cytokine, the people can kill in the pathogen, can kill in infected cells, and without progression of disease, they will recover, get a healthy lung function again. However, some patients cannot control cytokine production, cannot stop infiltration of neutrophils. What happened? The lung leading to failure because the damage of normal cells, lung cells function, okay, and also cause tissue damage and edema occurs and leading to lung failure. Okay, that's all the pathophysiological effect by infection of SARS-CoV-2 virus. Okay, let's use this slide taken together. What's the event here? After infection, you are going to change the setting RAAS, okay, leading to pro-inflammatory state in the vessel, okay, in the tissue. So you damage the endothelial cells, it leading thrombosis in the venue. And also you recruit more neutrophils in the venue, in the capillary, and they will release a lot of nets, it's a web. And this combined with platelets, thrombosis, which will occlude all the venue, which aggravate the severity of this disease, okay? And those combined those events, okay, toxic substance cytokines, and were leading to acute respiratory distress syndrome. We call it ARDS, leading lung failure. There's another very important event I want to mention. Even the patient survive after ARDS, their lung function still damaged, cannot fully recovered. The reason why? Because the later event, they will cause lung fibrosis. Okay, why is a lung fibrosis? During regeneration or healing, the functional lung cells cannot be reset. They recruit different type of cells, fibrocytes, which are cells without the oxygen exchange function. So you recruit a non-user cells in the lung. We call them lung fibrosis. So the patients survive from COVID-19. They have difficulties to breathe. Okay, they are limited their exercise or sports activity in later on their life. And here, this slide tell you another most very important event is its activation of P-selectin, which leading to thrombosis in the patient. Also, is very important the phenomenon to deter this disease. Okay, you can see that in this tomography CAT scan. You can see a lot of blood flow up clot. Okay, because of thrombosis. So let's tell you another thing. This also is a very good target for therapeutics development. Okay, now we are going to use this slide to tell you some people without any symptom after infection, some people developed severe disease symptoms, okay, due to the low titer or affinity of the virus or weaker virus. They develop milder immune response. They undercheck all the cytokine release and the number of leukocytes, they will recover. Okay, however, some people should get received more risk strength of virus or get a high virus titer, will generate a lot of difficult immune response. And those leukocytes will release a lot of huge combined or cartel cytokines, which is leading to cytokine storm and of course the liver damage, edema, and also leading to failure organs, okay, contribute to the higher mortality. Okay, this is the whole picture, okay, for the immune response to the SARS-CoV-2 virus. Okay, taken together here, in the peripheral blood, we can see increased number in the leukocytes, lower numbers in T cells and NK cells. Okay, higher neutrophils will generate a lot of different cytokine storm, and with the NETs, thrombosis, okay, and the T cells is much lower. Okay, and you can see the X-ray film. You can see the white spot. Okay, develop the pneumonia. Okay, and this one is I like this data very much. It tells very important story. Okay, this data was derived from 148 patients. Okay, 87 male, 61 female. Okay, depends their medical data. They classify into 3 categories. Okay, depends their saturation of oxygen and the respiratory rate. Classify into 3 groups: mild, moderate, and severe. Okay, mild is 94% of saturation, 90 to 94% is the middle. Severe is less than 90. Okay, and for the times for breathe under 24 is mild. Between 24-30 is a moderate. Higher than 30, high frequency, we call them severe. Okay, we study the difference in the white count of those 3 populations, and you can see that total leukocytes count for the mild have 7,225. Okay, total leukocytes count compared to severe, near to double. So you tell that even in the peripheral blood, white count is increased. That's an index of inflammation, systemic inflammation in the patient. Okay, let's look at each subcellular leukocytes on this data. Here, neutrophils, mild is 59, and the increase in the moderate patients or symptom patients, 80, severe 88. These data suggest neutrophils is the number of neutrophils is an important prognosis factors, right? Okay, and they're very significant. Another one, monocytes, also is 7.6, 5.11, 3.5. So the statistic p-value is less than 0.05. It suggests a macrophage number is increased with the severity of this disease. And also let's look at the eosin and basal also decrease. So it's suggesting one thing: PMN leukocytes are increased for monocytes and the lymphocytes. Here's a lymphocyte. Here's a lymphocyte. Is decreased. So it suggests lymphocyte and macrophage decrease in the severe form of COVID-19 patient, but the PMM, including the neutrophils and the EOS in the basal, are upregulated. Okay, so that's the ratio. Neutrophils over the lymphocytes, neutrophils over the monocytes. So you see a lot of huge numbers suggesting neutrophils is very important. Okay. So in this data suggestion, how to manage infiltration neutrophils is a very key point for reduce or minimize the severity of this disease. Another one, this also has interest into the 2 population or patients. Okay, one diabetes, another one people suffering hypertension. You can see that diabetes patient has a higher leukocytes count, higher number and neutrophils over lymphocyte, neutrophils over the macrophage. Okay, almost done. Thank you. Thank you. Okay, you can see that their number is higher. And again, you can see hypertension has the same way. So this data suggesting one thing: people suffering with diabetes, hypertension, and another one, I forgot to tell you, the age. You see the age, mild 39, moderate 48, severe form 57. suggests the 3 parameters: age, diabetes, hypertension, which is a high risk population in of people to suffer COVID-19. Okay, I really like this study. Okay, now the only 5 minutes I'm going to do very, very fast to talking about the treatment. Okay, I told you, right? The life cycle is a good target. Okay, you can use the blocker or inhibitors to block the protease, block the ACE2 binding, and then you can change the pH value in the endosome using the hydroxychloroquine, which can elevate the pH value and inhibit the protease in the endosome. And also use the reagent or inhibitors block translational transcription. Okay, and another one you can use antibody tocilizumab, which against IL-6. Okay, minimize cytokine storm in this COVID-19 infection event. So this is current treatment used COVID-19. Furthermore, there's another issue here I did not address in the previous slide. Complement. Complement is the protease exists the serum, which will cause the damage or infect the cells by punching the hole or cell membrane in the cells. Okay, so people try use a anti-C3 complement, this protease anti-C5 to minimize damage or lung. Okay, that's another regimen, another way, alternative way. Here I'm going to mention the drug development. Usually for the vaccine development, take 15 minutes here, right? 15 years, I'm sorry. Okay, from bench work to clinical trial. However, less than 1 year, we got a vaccine developed because we got experience to doing the SARS, right? And also we can do a lot of clinical trial at the same time because so many volume, so many patients, we can do clinical trial 1, 2, 3 at the same times. That's the reason why we do have this vaccine in 1 year only. Okay, and then we can make a vaccine from the inactive form of a partial of particles, and also use the more of the advanced one, use the messenger RNA as the vaccine, which is very, very powerful. Okay, due to time, I'm not going to go over very detailed. Here's the 6 vaccines available. Okay, and I believe that you guys has got a lot from the China. Okay, and I don't know it's what's the effect in Indonesia. Yeah, okay, we're still looking for it. Okay, in the end, I'm going to show you some campus life for the foreign student. It's most student. Noah, you are not here. Okay, they're all students here. Okay, here which is very close to Bio 11, Taipei 101 building. Okay, here, and here's affiliated hospital. Okay, you see their kids family studying TMU, and very close to, we are very close to the Taipei 101. It's a very good sign for watching firework during the new year. And here is the annual party for my institution. Okay, that's the former director. He will be here later. Here's, we take the whole group picture here. You can see this guy, Noah, and he is the one of member of your faculty, right? And a student. He's pursuing his PhD degree in microbiology. Okay, and in the end, I'm going to show you the TMU. We only 60 years old, but we keep moving, keep making progress in research and education. Here's this recent ranking 18 in PhD state. Hey, what happened? Okay. Now, the very important thing tell you that we are 10% of foreign students. Yes, and I forgot to tell you, we have 93 students from Indonesia, 75 pursuing people. Yes, and echo, right? Okay, I'm going to stop here. I would like to address one. This is Ufa from UGM. You know her? Okay, Ufa. And this is I forgot the name. She is from Aceh. Okay, okay. Yes, yes. And this auntie from the UGM. Okay, that's the master degree. Okay, thank you very much. That's my talk. Thank you.
Okay, we would like to thank the speaker, Mr. Jung Sang, has delivered the material in an extraordinary ways. Give applause. Okay, ladies and gentlemen, that was the presentation at the general lecture. We discussed leukocyte action on SARS-CoV-2 and other virus-based infection. So we continue. The next session is discussion. The question can be in English or Indonesian language. We will try to translate your question. Okay, if you have a question, you can raise your hand, and so that the committee in here can help me identifying your ways to interact with Jung San Chang, or you can write the question in the chat room. Okay.
Here.
Any question? Okay, I think we also have 2 questions already in the chat room. Okay, I would probably take one for from the question from lecturer biology education from Ibu Ratna Dewi. The question is, what is the medicine for someone who has tested positive for COVID-19? Do those who have been positive for COVID-19 do not need to be injected with the COVID-19 vaccination? Okay, Mr. Jungsan, please.
The best medicine
You can answer this question directly.
Without vaccination before.
Hello.
Okay, I just according to my opinion, I think the best treatment is prevention. Okay, wear your mask. Okay.
You can see in the chat room, Mr. Jung Sang.
Somebody asked.
Okay, someone. Okay, I answer the question. First one is still infection. How to tell secular. That's the thing that body which is infected. Okay. Because contact transmission is still very important. I mean, it's dangerous contact with the COVID-19.
Mr. Jung San, hello.
Yes.
Hello, Mr. Jung San.
Yes.
I can hear your voice not clear.
Okay. Let me double check my incarnation. Can you hear me? Hello.
Hello.
Hello. Can you hear me?
Not clear. Your sound is not clear.
Oh, really? Let me working on it. Strange.
You need to close your video.
Close to my video. Okay, can you hear me now? It's clear?
Okay.
It's better?
Yeah.
Can you hear me?
Yeah, a little clear. It's okay. Can you start the answer? Okay.
It's okay. I answer the question now.
Not clear, yeah. Not clear. Still not clear. Mr. Jung.
Okay. Give me a second. Let me set in my.
Aduh, apa sih?
Let me set in my. Okay, now just it.
Still not.
I mean, you just close all of the
Close
cells.
it.
Yeah.
Okay, I think run better, Prof. Prof.
Can you hear me? Is it clear?
Okay. Yes, clear, Prof. I think we
Okay, thank you.
run
Okay, I'm gonna
better,
answer the questions.
Prof.
Okay, they asked me how to taking care of the you can hear me now?
Okay.
Okay. Okay, I'm going
Yes,
to ask them
yes,
question. One of the
it's
students asked me
clear. It's clear. This is
how to
clear.
taking care of the things of infected with the virus. I think the content just is the prepare for anything the way prevent the spreading. Okay, and the second question, let me see. I would like to issue the mutation.
Question in the group.
Okay.
The second question,
Yes.
Hello, do you hear my voice? Hello. Hello, Mr. Jung Sang. Do you? Okay. Thank you very much. Okay, this is the question for how to the best take care that body which is the infected by this virus. Okay. You can read.
Personally, in the handle in the dead body. And I because we don't have them guard in the entire way. But look at the data and the handle in China, you on the disease on the is best way to start burn. Yeah, is the best way to during those tremendous dead body. That's the best way. And people we don't know how long the virus will survive in the dead body. Okay, a lot of studies show that virus is very resistant to this, right? They can stick on the metal stuff. This so infected the patient and the dead body also. This, right? This. So I don't know what kind of method you guys are handling those that person in this.
The dead body in underground or the land.
Oh, so you don't
Soil, yes.
need this. So